awak yang tu lah. Jangan lupa subscribe channel kita, tanda sokongan. Terima kasih. Assalamualaikum and hi everyone. Welcome back to my channel. So today we are going to discuss about electric field. So I want to discuss 4 examples that related to the subtopic, which is subtopic 1.2, electric field. Okay? Alright, look at the definition of the electric field. So the electric field is actually a region in which an electric force will act on a charge that is placed in that region. Means that, let's say here, okay, I change to pen first. Okay, let's say here we have a charge which is Q1, alright, and this is the line of the electric field, okay, around the charge. So, look at the area around the charge. So, this is the region, okay, or when we place another charge in this region, what happened? This charge will experience the electric force. For example, at this position, let's say we name it as position A or point A. So here we can find what is the electric field strength at point A. So we can put as EA, where the equation is equal to KQ. Q here is the charge that refer to the first charge here, Q1, over RA squared, where RA is refer to the distance between the charge and this position or this point A. So this is RA. Okay, so we can calculate what is the electric field strength at this point. So when we have a charge, okay, so when we have a charge here, we put a charge here at this point and we name it as Q2. Okay, let's say we put a positive charge here. Okay, so when we put a charge of Q2 at point A, we actually can calculate what is the electric force that will act on that charge. The equation is referred to E, where E is the electric field strength at point A. And when we put a charge of Q2 at point A, we can calculate what is the electric force on that charge. So let's say I put as F2 over, here should be Q2. Okay, and it's equal to K. So the electric force at point 2 or electric force on point 2 must be due to the first charge. And the equation should be Q2 Q1 over R12 squared over Q2. Okay, so now you can see when we cancel out this Q2, so let's say this is the bracket. So you can see that finally the equation of the electric field strength at point A is equal to K Q1 over R squared, where R12 is the distance from this charge to this charge and it's RA. Okay, so the definition of the electric field is defined as a region in which an electric force F will act on a charge, okay, when the charge is placed in that region. Okay, for this example, we have Q2 tadi. So kita letak Q2 dekat point A. What happened to this charge? This charge will experience an electric force, which is F2. Okay, so we can use this equation in order to calculate what is the electric force that act on Q2. So kalau kita dah ada nilai EA, EA is the electric field strength on point A, then kita ambil Q2, kita letak pada point A. What happened? So this charge Q2 will experience the electric force. And if you want to find what is the electric force that act on Q2, we can use this equation. Alright, so here you can see the electric field lines from the positive charge and this is negative charge. So you must know the pattern. Okay, so you must know how to draw the electric field lines around positive charge and negative charge, where the arrow for the electric field lines from the positive charge should be outward from the charge, while for the negative charge, the electric field line should be inward. Okay, so this is the equation, the general equation for the electric field strength. As you know, it's defined as the electric force or the electrostatic force per unit positive test. So here we have E, where E is the electric field strength equal to electric force or the electrostatic force per unit positive test charge. Q naught is the test charge. Charge Q2 tadi yang kita bawa dan kita letakkan dekat point A tadi. Okay, so this is the test charge. Alright, that acts at that point in the same direction as the force. So now when we want to find what is the magnitude of the electrostatic force on the test charge Q2 tadi yang kita tengok example tadi, so we can calculate by using this equation. If we have the value of the electric field strength at point A just now, then we can straightly calculate what is the electrostatic force, okay, that act on that test charge, and it's equal to Q naught, okay, the amount of the test charge, okay, the charge of the test charge, and times the electric field strength E at point A. Okay, contoh tadilah yang kita dah tengok tadi, this one. Okay, so here Q2 kita bertindak sebagai test charge. Alright, and finally we can calculate where F2, okay, wait, okay, where F2, okay, at point A is equal to EA, this is the electric field strength at point A, times the test charge. So just now we have the test charge of Q2. So now we can calculate this one. Okay, so here I show you the derivation. So EA equal to F2 over Q2. So this is the electrostatic force between the test charge Q2 and the point charge Q1. Alright, over the test charge. So here is the test charge. Test charge. Ini adalah charge yang kita letakkan dekat point tu. Dekat point A tadi. Okay. And this is the electrostatic force between the test charge Q2 dengan Q1. Boleh. So, bila kita derive, kita akan dapat formula yang sama. Okay. Alright, good. So, remember the unit. Okay, make sure you use the SI unit. So, we always use Newton per coulomb. And it's a vector quantity. Means that when you leave your final answer, make sure you have the magnitude of the electric field strength and please mention what is the direction of the electric field. Okay? Alright, so now let's move to the first example. Okay, let's read example 1 first. So, determine A, the electric field strength at a point X at a distance 20 cm from a point charge Q equal to 8 microcoulomb. Okay, so here you can see we have the positive charge 8 microcoulomb and we want to find what is the electric field strength at point X here. Okay, B, find the electric force that acts on a point charge Q equal to negative 1 microcoulomb when the point charge Q is placed at point X. So means that we have another charge and we put at point X. So we want to find what is the electric force that act on that charge. So now let's try to solve for question A. Where question A, we want to find the electric field strength at point X, where the equation should be KQ over Rx squared. So it's equal to 9 exponent 9 and the charge is 8 microcoulomb and the distance from X to positive 8 microcoulomb is 20 centimeter. Okay, squared. Okay, so press your calculator. So the answer is equal to 1.8 times 10 power of 8 Newton per coulomb. Okay, so this is the answer. Alright, B. So let's say we have another charge which is negative 1 microcoulomb and we place at point X. Okay, so here we have another charge which is negative charge, and this charge is negative 1 microcoulomb. Alright, so we want to find what is the electric force that act on that charge. Okay, so for question B, so as we know, the equation of the electric field strength at point X, where the position of Q, so it's equal to F, the electrostatic force on the Q, small q, over the magnitude of the charge Q, okay, small q. So we want to find what is the electrostatic force that act on Q, okay. So we can rearrange the equation as we have the value of the electric field strength at point X. So we already know what is Ex, then we can straightly calculate what is Fq, where Fq is equal to Exq, and Ex is 1.8 exponent 8, and the charge here is negative 1. Make sure you don't put your negative sign in your calculation because we already consider the direction. Okay, so the direction, so what is the direction? So let's say I put the purple color, so this one negative and this is positive. Alright, so the direction is must be in this direction. Okay, attracted. So negative charge must be attracted to the positive charge. So the direction of the electrostatic force on Q should be to the left. Okay, because negative will be attracted to positive charge. And when we try to calculate what is the Fq, so we're going to have 180 Newton, and this is the magnitude of the electrostatic force. And how about the direction? Therefore, the direction, okay, the direction of the electrostatic force should be to the left. Ataupun kita boleh tulis sebagai towards Q. Okay, so let's move to example number 2. Okay, so now example 2, we have 2-point charges. Q1 is negative 3 microcoulomb. So Q1 is equal to negative 3 microcoulomb. And Q2 also negative charge, which is negative 5 microcoulomb. Okay, negative 5 microcoulomb. Alright, and they are placed 12 centimeter and 30 centimeter from point P. Okay, if you can see from the diagram here, where Q1 is 12 centimeter to the left of point P, where Q2 is 30 centimeter to the right of point P. Okay, so now we want to determine the magnitude and direction of the electric field intensity at point P. Okay, so before we start to calculate what is the resultant or the net electric field intensity at point P, we need to draw the direction of the electric field at point P due to first charge and the direction of the electric field at point P due to the second charge. Okay, so now, so on point P, okay, you can draw here. So P, so we need to consider P as positive. So we just put a small positive sign here. Okay, because positive will be attracted to the negative. So this will guide you to draw the direction, the correct direction for the electric field on P due to charge 1. Okay, so in this direction, I will put EP1, means that electric field on P due to charge 1. And positive, negative, so we have direction to the right, so it's EP2, the electric field strength on point P due to the second charge. So now let's calculate what is the electric field strength at point P due to the first charge. at point P due to the first charge, S equal to KQ1 must be charge 1 over the distance between point P. The distance between point P to charge 1 is 12 centimeter, and we put as R1. Okay, so it's R1 squared. Alright, so you can straightly substitute. Okay, so this one is squared. Okay, so we have 9 exponent 9 times, the charge is negative 3 microcoulomb, but please ignore the negative sign in your calculation because we have considered the direction. Okay, so times 10 power of negative 6. Okay, so for this one, we just ignore the negative sign. Sorry. Okay, so I will put here. Okay, ignore negative sign in your calculation. Okay, so you can see here no negative sign in your calculation. Alright, so now over R is in centimeter, make sure you change in meter. 12 power of negative 2 squared. Okay, and press your calculator. So the answer is 1.88 exponent power of 8. Exponent power of 6. Okay, and the unit is Newton per coulomb. Okay, so this is the magnitude of the electric field on P due to the first charge, and the direction is to the left. Okay, ataupun kita tulis sebagai towards Q1. Okay, and for the second one, so we have EP2, where EP2 is KQ2 over R2 squared. So we can substitute all the values. Make sure you ignore the negative sign of negative 5 microcoulomb in your calculation. We just put 5 microcoulomb over the distance between point P to Q2 is 30 centimeter. Make sure you change in meter. Okay, and the final answer for EP2 is 5.00 exponent 5. Okay, Newton per coulomb, and then the direction is to the right. So we take the positive sign. The positive direction is to the right. The negative direction is to the left. Okay, so this one is towards Q2. Okay, so we want to find what is the intensity, the electric field intensity at point P. So we want to find the resultant electric field at point P. So means that the total. So if you can see, the direction for both electric field strength is in X direction, which is to the left and to the right. So we can just read the total. The electric field strength at point P is equal to EP1 plus EP2. So you can look. So now look at here. Since EP1 is to the left, the direction is to the left, we must put negative sign here. Okay. So EP1 now is negative. The direction is to the left. Therefore, it's equal to negative 1.88 exponent 6 plus 5.00 exponent 5. If you can see here, we have two different directions. So 1.88 exponent 6 is the magnitude of the electric field on point P due to charge 1, but the direction is to the left. So when you total up the electric field strength at point P, make sure you consider the negative sign as the direction is to the left. Okay, so the answer is negative 1.38 exponent 6 Newton per coulomb. Okay, so now the magnitude of the electric field strength at point P, or we can write as EP. Therefore, EP is equal to 1.38. So this is the magnitude, and the direction. The direction is to to the left. Okay, so we finish example 2. We have B. Okay, so for question B, we want to find the net electric force exerted on Q naught. Okay, we bring a test charge of positive 1 microcoulomb and place the test charge at point P. So what is the electric force that exerted on that Q naught? Okay, so as we know, we have calculate the EP, which is electric field strength at point P just now. So it's equal to 1.38 times 10 power of 6. Okay, therefore we can find by using the equation of EP is equal to F of the test charge Q at point P over Q naught. Okay, based on this equation, we can straightly find what is FQP. By rearrange this equation, therefore, FQP is equal to EP Q naught. And this is 1.38 times 10 power of 6. And given that the test charge is positive 1 times 10 power of negative 6 microcoulomb, and the final answer should be 1.38 Newton. And this is the magnitude. But the direction, how about the direction? So the direction is to the left or towards Q1. Alright, so question C, we want to determine the distance of a point. Okay, a point from Q1. So let's say we put a point P from Q1 where the electric field intensity at point P is 0. So the question gives us the condition where the net electric field ataupun the total electric field at point P is equal to 0. Okay, so we want to determine the position of point P from Q1 where the electric field intensity at point P is equal to 0. Okay, kalau tadi point P ni 12 cm from Q1, kita dah kira total electric field strength at point P is not equal to 0, right? So now we will try to move the point P to another position on the line, and we want to find what is the position of this point from Q1 where the total or the net electric field or the electric field intensity at point P is equal to 0. Okay, so we can write the total electric field at point P is equal to, based on the direction, EP2 is to the right, so it should be positive, plus EP1 is to the left, and it's negative EP1. Okay, so you must remember that when we consider a point, we take it as positive sign here. Okay, so P as positive sign, so positive, negative, so due to P1, so this will be attracted to P1, Q1, so it's to the left, and EP2 will be attracted to the right. Okay, so the condition given by the question is the total EP is equal to 0. So now let's write here EP is 0 and it's equal to EP2 minus EP1. Therefore, EP2 equal to EP1. Okay, so EP2 is KQ2 over R2 squared equal to KQ1 over R1 squared. Okay, so now this is the trick. Okay, the trick is we don't know what is the distance here from point P to Q1. Okay, we want to find this distance since the question states that determine the distance of a point from Q1 from Q1. So from Q1, so we put as X here. While for the another part here, so since we know that the distance from Q1, okay, the distance from Q1 to Q2 is 12 centimeter plus 30 centimeter, which is from the previous question, we have 42 centimeter. So if the distance between Q1 and Q2 is 42 centimeter, so here is X, and this remaining distance should be 42 minus X. Okay, 42 minus X. Okay, so this is the trick you must know. Okay, where R1 here is X. Okay, distance between point P to Q1, and R2 here is 42 minus X. Okay, kita terbalik ni. Okay, ni terbalik. Okay, padam balik. So here is R2, so 42 minus X, and R1 is X. Okay, make sure jangan terbalik So we can cancel K first, and then let's substitute all the values. So Q2 is negative microcoulomb. Make sure you ignore the negative sign. So 5 exponent negative 6 over 42 minus X. So it's in centimeter, 42 centimeter. Make sure you change in meter. Okay, so it should be 0.42 minus X. And it's equal to, Q1 is 3 microcoulomb. And R1 is X. Okay, so now this one we have squared here. Okay, don't forget. Please don't expand the quadratic equation here. So we will bring the x squared to the other side so that all the unknown in one side only. Okay, so we have x squared over 0.42 minus x squared equal to, so we bring the 5 microcoulomb downward. Okay, so 3 times 10 power of negative 6 over 5 times 10 power of negative 6. So now we can cancel the exponent negative 6 here. Okay, so next we can take the square root for the both sides since we want to cancel the square. Okay, here we can cancel square, square, square. And then we can write x over 0.42 minus x equal to square root 3 over 5. It's equal to 0.7746. Okay, make sure you check Okay, so x is equal to 0.7746 times 0.42 minus x. Therefore, x is equal to, so you can rearrange this equation. So I will straightly write 1.7446 x equal to 0.32533. Therefore, x is the position of point P from Q1 is equal to 0.183 meter. Okay, so this is the answer. Okay, so now let's proceed to example number 3. Okay, now question number 3. Here we have 2 point charges, Q1 which is negative charge 2 nanocoulomb, and then Q2 3.2 nanocoulomb, and they are placed 3 centimeter apart as shown in figure 6. Okay, so determine the magnitude and direction of the resultant electric field intensity at point M. So given that the permittivity of free space is 8.85 exponent negative 12. Okay, so before we start, so we need to draw the direction of the electric field strength on point M due to charge 1 and charge 2. Okay, so you can look at here. So first of all, I'm going to draw the hypotenuse line for this triangle. Okay, so let's say this is okay, so this is the line. Okay, so on point M, okay, we have, so let's say this is positive. So positive, negative. So look at here, we have positive, negative. So the direction of the electric field at point M due to the first charge is in this direction. Okay, so attracted to Q1. So I will put EM1. And here we have positive and positive. So this one should be repel. So the direction is to the right. Okay, in this direction. E on M due to the second charge. Okay, so when we try to transfer, okay, and look at here, we have EM2 and this is EM1. Okay, where the angle here, okay, so this is the y-axis and this is the x-axis. So we can find the angle here by using this triangle. Okay, so now let's calculate the angle theta. So I am going to use inverse tangent. So inverse tangent is equal to 3 over 4. Okay, and then theta is equal to 36.86 degree. So here is the angle theta, which is 36.86 degree. Okay, so now for the electric field strength EM1, we need to resolve into two directions, which is in y direction and in x direction. Okay, so we finish draw all the direction for EM1 and EM2. So you can see here, EM1 we have x and y, but EM2 is to the right, so no direction in y component. Okay, so now let's calculate the electric field strength E M due to the first charge 1. So it's equal to, okay, KQ1 over R1 M squared. Okay, so in the question, given that the permittivity of free space is 8.85 exponent negative 12, so you can calculate K, where K is equal to 1 over 4 pi epsilon naught. Okay, so now let's substitute the value of K, which is 9 exponent 9. And then Q1, given that Q1 is equal to 2 nanocoulomb, and over the distance between point M, look at here, we have point M. So the distance from point M to Q1 is 5 centimeter. So this is a triangle. So 3, 4, and the hypotenuse, you can calculate the hypotenuse of the triangle is equal to 5.0 centimeter. Okay, so when you substitute here, we have R1M squared is equal to 5 exponent negative 2, because we need to change into meter squared. And then EM1 is equal to 7.2 exponent 3 Newton per coulomb. Okay, and how about electric field for second charge EM2? So it's equal to KQ2 over R2M squared, and K is 9 exponent 9. Okay, and we have the charge of Q2 is 3.2 nanocoulomb. Okay, and the distance between point M to charge 2 is 4 centimeter. Okay, so it's equal to 4 exponent negative 2 squared. Alright, so EM2 is equal to 1.8 exponent 4 nanocoulomb. So now let's try to draw a table in order to divide x component and y component. So this is optional. Okay, so not compulsory for you to draw the table in order to answer this type of question. Alright, I'm just to show you, okay, how to divide E1M into x and y component correctly. Okay, alright, so here we have x component. Okay, NC negative 1, and this is the y component. Okay, so this is E1M and this is E2M. So refer to the direction of the electric field on point M just now. So you can see here that E1m, so we have y components and x components. So when we write the E1mx, so it's equal to E1mx, which is in x component. So the direction is to the left. So when to the left, so we put negative sign here. Okay, so we have negative. So E1m cos, okay, because the angle is beside the lines of E1mx, so cos 36.9 degree. Okay, and it's equal to, so E1m, okay, kita dah kira tadi, E1m here is negative 7.2. So negative 7.2 exponent 3 cos 36.9. Okay, and it's equal to 5.75 times 10 power of 3 Newton per Coulomb. Okay, and this is the direction is to the left. So this is negative, so it's to the left. Okay, and how about in y component? So we have E1 my is equal to E1m sine 36.8. Sorry. So now we have E1my. So we have E1m sine 36.9 degree. Where E1m, kita dah kira tadi, it's 7.2 exponent 3 sine 36.9. And the direction is upwards, so it's positive. So you can see here, E1my is equal to 4.32 exponent 3 Newton per Coulomb. Okay, so now look at to E2m. Okay, so since the direction of the EM2 is to the right, so no angle, so no need to resolve into x and y component. So means that we just have EM2 in x component. Okay, no value for y component. So for y component, it's equal to 0, but in x component, it's equal to E2mx is equal to 1.8 times 10 power of 4. Okay, kita dah kira tadi kan? So, this one. So, here we have 1.8 times 10 power of 4 Newton per Coulomb. Okay, so now, let's try to calculate the resultant. Okay, the resultant electric field at point M in x direction. So, it's equal to negative 5.75 exponent 3 plus 1.8 times exponent 4, and it's equal to, okay, and it's equal to 1.23 exponent 4 Newton per Coulomb. Nanti you check, okay? Alright, and for the x component, and for the y component, we just have E1my from electric field on M due to first charge, so straightly 4.32 exponent 3 Newton per Coulomb. Alright, therefore, the resultant electric field on point M is equal to square root total electric field on M due to x component squared plus y component. Okay, so since y, here we have 4.32 exponent 3, so you can just substitute 1.23 exponent 4 squared plus 4.32 times 10 power of 3 squared. Okay, and the electric field strength, okay, the magnitude or the resultant electric field intensity at point M is equal to 1.3 times 10 power of 4 Newton per Coulomb. And how about the direction? And the direction is equal to inverse tangent, okay, inverse tangent EY over EX, okay, and substitute the value, then you will get theta is equal to 19.4 degree, okay, and it's above positive x-axis, okay, above positive x-axis means that you can see here total EMY is positive, so the direction is upward, so this is total EY, and total EX is also positive, so total EX, okay, and then the direction of E, the resultant electric field on M, which is equal to 1.3 exponent 4 Newton per Coulomb at this angle of 19.4 degree, and this is in positive, above positive x direction. Okay, kalau belah sini, ini adalah negative x direction. So we finish question number 3. So let's proceed to question number 4. So example 4, we have a figure that shows 2-point charges, Q1, which is positive 10 nanocoulomb charge, and Q2 is negative 10 nanocoulomb, and they are placed 15 centimeter apart. So question A, calculate the coulomb force on the charge Q1. Okay, so we want to calculate what is the coulomb force on charge Q1. Okay, so this is Q1 and this is Q2. So in order to answer question A, so we want to find what is the electrostatic force or the coulomb force on Q1. So F1 due to second charge, so it's equal to K Q1 Q2 over the distance between charge 1 and charge 2 squared. Okay, so we just substitute all the values. So this one is positive 10 nanocoulomb. So Q2 is the negative 10, but don't insert the negative charge in your calculation. So just put 10 times 10 power of negative 9 and over R12 is 10 centimeter squared. Okay, so the magnitude of the electrostatic force on charge 1 due to charge 2 is equal to 9.0 times 10 power of 5, negative 5 Newton. Okay, so this is the magnitude. And how about the direction? Okay, so the direction, so now, so on Q1 means that positive, negative. So here is positive, so the positive charge will be attracted to the negative charge, and then the direction of F1 on, the direction of F1 due to 2 should be to the right. Okay, so in this direction, F on 1 due to 2, so the direction is to the right. Okay, or towards Q2. Okay, so question B, we want to calculate the electric field strength at point Y. So before we start, we need to draw the direction of the electric field strength on Y due to Q1 and on Y due to Q2. Okay, so we consider Y as positive. Okay, so positive, positive. So the electric field on Y due to Q1 should be to the left. Okay, should be to the left. So we label as E on Y due to the first charge. And electric field strength on Y due to the second charge should be to the right, EY2. Okay, so now when we want to find the total, okay, the total electric field strength at point Y, so it's equal to EY1 is to the left, so it's negative EY1 plus EY2. Okay, so now we substitute the equation negative k q1 over r1 squared plus k q2 over r2 squared. Okay, so now substitute the values. So we have negative 9 exponent 9 and q1 is 10 exponent negative 9 over r1 is, so the distance between y and q1 is 5 centimeter. So 5 times 10 power of negative 2 squared. Okay, jangan tertinggal squared. Plus, okay, 9 exponent 9, okay, times 10 exponent negative 9. Alright, make sure no need to substitute the negative charge. Okay, so over, okay, so R2 is the distance between point Y to charge Q2. So where it's 5 centimeter plus 10 centimeter and it's 15 centimeter. So 15 times 10 power of negative 2 squared. Okay, so press your calculator here, you will get negative 3.6 exponent 4 plus 4004 times 10 power of 3. Okay, and then the final answer, the electric field, this one should be, okay, the total electric field strength at Y. Okay, so the answer is equal to negative 3.2 exponent 4 Newton per Coulomb. Alright, therefore, the magnitude of the electric field strength at Y is equal to 3.2 times 10 power of 4 Newton per Coulomb. And the direction, since the answer is negative, so the direction is to the left. Okay, so finish part B, and now let's proceed to part C. Okay, question C, we want to calculate the electric field strength at point X. Okay, so now refer to point X. Here we have, okay, in this direction. Okay, so this is positive, so the direction should be repel the Q1 charge. So in this direction. Okay, lukis dulu yang ini. E on X due to the first charge. Okay, and here we have positive and this is negative. So this point should be attracted to negative charge. So in this direction. Okay, so this is E on X due to the second charge. Alright, so now look at here. Okay, so E1X is to the right in this direction, where E1Y is upward. Okay, so now look at the angle. Okay, we can find the angle here by calculating the angle of this triangle. Okay, so let's say we draw a triangle. So here is the hypotenuse and this is the base. Okay, so we want to know what is the angle here. Since this is 5 centimeter and this is 15 centimeter, so by using cos theta 5 over 15, therefore the angle theta is equal to the inverse cos of 5 over 15. Okay, and the angle is equal to 70.5. Okay, theta is equal to 70.5 degree. So here is 70.5 degree and here should be 70.5 degree as well. Okay, now let's draw all the direction of the electric field on point X. Okay, so let's say this is E1 and this is E2. Okay, and the charge is here in this direction. Okay, so we have Q1 positive and this is negative. So they are same magnitude, nilai dia sama, but the sign of the charge positive and another one is negative. Okay, so you can see, right, we have a triangle here, and now the angle 70.5. So in this direction, so E1x, okay, if here is 70.5, so here also 70.5. Okay, same goes to this one. If here is 70.5, okay, so here is 70.5, okay, in this direction, here also 70.5. Alright, so now E1x, so we're gonna have E1y, and so here we have E2x, okay, the green color is E2x, and here is E2y. So if you see here, E2y is equal to E2 sine 70.5, but it's downward, so means that it's a negative value. Okay, and how about E1y, where E1y is upward? Okay, so it's equal to positive E1 cos, and E1y is upward, so it's positive, and E1y is upward, and it's equal to positive E1 sine 70.5. Okay, so when we write here, E1y is positive E1 sine 70.5, and E2y is equal to negative E2 sine 70.5. Look at here. Okay, so the magnitude is the same magnitude, okay, but the direction is opposite. So when we calculate the total, okay, so the total EY is equal to E1y plus E2y, right? And it's equal to E1y, you akan dapat nilai positif, positive E1 sine 70.5 plus negative E1 sine E2 sine 70.5. Okay, and since the magnitude of the charge Q1, okay, nilai Q1 ni tadi berapa? 10 nanocoulomb, and this is also 10 nanocoulomb. Therefore, E1, okay, jarak mereka sama kan? E1, so this is 15 cm. This is also 15 cm. Okay, since the distance are the same and the magnitude pun sama, distance daripada Q1 ke X and Q2 ke X pun sama. Okay, that means the electric field strength due to Q1 is equal to the electric field strength due to Q2. Okay, so kalau awak kira, awak akan dapat nilai, okay, kalau awak kira, the value of E1 is equal to E2, the magnitude dia. That's why EY, yang nilai ini akan dapat sama lah. Okay, dia akan jadi kosong. Okay. Okay, now how about in X component? Okay, so dia akan jadi E1X plus E2X. So it's equal to E1 cos 70.5 plus E2 cos 70.5. Okay, alright. So if we try to calculate E1, kita nak tengok betul ke E1 ni sama dengan E2 kan? So E1 is equal to KQ1 over R1 squared. Okay, we substitute all the values. Okay, so 10 and R1, the distance from X to Q1 adalah R1 15 cm. Okay, and it's equal to 4 times 10 power of 3 Newton per Coulomb. Okay, kalau you kira E2 pun sama, KQ2 over R2 squared. Okay, and it's also the same value here, 10 nanocoulomb over the distance between X and Q2 also 15. Okay, so nampak nilai dia sama kan? Kalau you tengok sini, bahagian sini dengan ini sama. So the value is 4 times 10 power of 3. Alright, so here we can just substitute 4 exponent 3 cos 70.5 plus 4 exponent 3 cos 70.5. This one is 70.5. Okay, so the value is equal to 1.34 times 10 power of 3 plus 1.34 times 10 power of 3. Therefore, the total electric field strength in X component is equal to 2.68 times 10 power of 3 Newton per Coulomb. Okay. And the total or the magnitude of the electric field at point X tadi is equal to total force in X component squared plus total force in Y component squared. Tapi sebab Y tadi dah kosong, therefore the electric field intensity at point X is equal to 2.68 exponent 3 Newton per Coulomb. Okay, so this is the magnitude and the direction is to the right. Okay, so the direction is to the right because the total EX kita dapat nilai positive value. Okay. See you in the next session. Don't forget to like, share and subscribe channel Madam Fika Fiki. Jumpa lagi. Assalamualaikum dan selamat sejahtera.